Hello friends, this video on electrochemistry part 19 is brought to you by examfear.com. No more fear from exam. Let's see how can we measure the conductivity of an ionic solution. Typically, to measure conductivity of a metal, what we do, we use the Wheatstone bridge in that format, right? You must have studied about the Wheatstone bridge in the physics. So we create a pattern something like this. We have 4 different resistors, right? And we make sure that there is no current that passes through this point A and B. In that scenario, we say R2 into R3 is equal to R4 into R1. I won't cover the Wheatstone bridge in detail because I know that has been covered in physics. You can watch that videos on Wheatstone bridge. So that is a way to find out the resistance of an unknown resistor, right? Similarly, here also we'll use Wheatstone bridge to find resistance of the ionic solution. But again, the problem with this ionic solution is if you see, is a liquid. It doesn't have a definite mass, right? How will you find L and A? Because I told that resistance is rho L by A, correct? So if it doesn't have any definite mass, definite size and shape, how will you find the resistance, right? Because it doesn't have any definite shape. Also, as I told that if you pass a current, right, if you pass the current, the composition of the solution is changing. If you pass a DC current here, for example, if you pass a DC current, you take a battery has a DC current. You pass the DC current over a period of time, the composition of the electrolytes changes. If the composition changes, that means the resistance will change, because resistance is nothing but resistance to the flow of current, and resistance to the flow of current is because of the viscosity of the solution and other property of the solution or other property of the electrolyte. If that changes, the resistance will change, right? So one problem is it doesn't have a definite shape. The second one is this electrolytes, when you use DC current, the composition of electrolyte changes. And the third one is again linked to the first one. When I say that electrolyte doesn't have a definite shape, so that means electrolyte solution we cannot connect to a bridge just like that, right? Because it needs to be something solid. Since it doesn't have any shape, you just cannot connect it. So these problems are solved. The first problem which I have, where I don't have a shape, a definite shape, that is solved by conducting cell. Conducting cell looks like this. This is my conducting cell. So let me write this term, conducting cell. So these conducting cells are specially designed, and there are various types of designs in the market actually. So they'll have some plates here, right? And it'll have some space to fill the electrolytes. So with this distance I'll call as length, from distance P to Q will be the L, and the cross section of this Q will be the area, right? Because at a given point of time, if you see this particular volume of electrolyte will be conducting. So using the proper vessel, and that vessel is called conducting cell, we can solve the problem of definite shape. For the change in composition of electrolyte on passing DC current, that can be solved by passing AC current instead of DC current. AC current, is alternating current, so it will change its polarity, right? So with that the electrolyte will not change its concentration over a period of time. Now if you see this particular conducting cell which is here, this is the example of conducting cell. It has 2 platinum electrodes. These 2 are the 2 platinum electrodes, P and S, and they are coated with platinum black. See why they are coated with platinum black? First, understand what is platinum black. Platinum black is nothing but it's a finely divided the metallic platinum, and that is deposited on these platinum using electrochemical process. We'll explain the electrochemical process of electroplating. We'll soon explain that. So using the electroplating method, this finely divided platinum is deposited, right? And we call, if you deposit layers of platinum on platinum metal itself, we call that platinization of platinum. We call that platinization of platinum. And why do you do that? See, it increases the surface area. For example, if I have a plain platinum, this is a plain platinum, and the second is I have a platinum plain, and on that you put lots of small platinum. So overall it becomes rough, right? So in that case the surface area increase. You can imagine in this fashion, you see a plane, for example, the cricket ground is a plane, right? You see the area of that, and the same similar area if you go to any hill station, let's suppose Himalaya or any hill station, if you calculate the total area, surface area, it will be more. Why? Because if you see, I'll show you. This is one surface. This is one surface. In this surface, I have all these kind of metals, right? Like this. Now, if you see the total surface area of figure 1 will be more than figure 2, even if the ground is same. Why? Because when you calculate, these areas are also exposed, right? And that's how you see the radiators which are used in the cars and air conditions, they have this kind of area so that the maximum amount of heat can be dissipated. So with this, the surface area is increasing. Similarly here, if you take the normal platinum metal, surface area is less. But if you put small do the plating of platinum, finely divided platinum here, the surface area increase. And here, if you know, the whole point is to have more surface area, because the surface area is nothing but the platform where my electrochemical reaction will take place, right? So if you have more surface area, you get better quality of catalytic action. So as I have told, they have the cross section area of A. So for example, this one you are seeing, right? This has the area of A. This also has the area of A. Right, they'll have this kind of structure here, right? Something like this on one side and something like this on another side. So these all will have area of A, these two are point P and Q exactly, which I am showing you, and they'll be separated by a distance L, right? So if you notice, for a given conducting cell, this is a conducting cell, let me write here also. So for a given conducting cell, these values are constant, because if it is designed in this fashion, the area of this platinum electrode will be same and the distance between the two platinum electrodes will be same, right? So this L by A will be constant for a given cell, right? And I know resistance is nothing but rho L by A, or 1 by K L by A. And this is constant, right? Since this is constant for a given cell, this is also called cell constant. Why? Because this is given constant for a given conducting cell, right? Conducting cell. This is a conducting cell, and this is denoted by G star. So instead of L by A, when R is equal to rho, instead of L by A, I can write G star. This equation I can write 1 by K G star. Correct? So for a given conducting cell, this value is constant. Now the question is, how can we derive the value? So there are two ways. One way, I can directly find the value of length between these electrodes. I can find the area of electrode. I can easily find L by A, and that is nothing but my value of G star. The other way I can do is, I can measure the resistance of this whole cell with a solution whose conductivity is known. For example, if I take KCl or if I take NaCl. And NaCl, the conductivity of NaCl or KCl is known at various concentration. Please note, the conductivity here for electrolyte is depends on concentration, right? So for NaCl or KCl, any standard solution, the conductivity is known. The chemists have done this experiment, and they have the values are pretty much there. You can search internet, you can see in a lot of textbook, those values are known, right? So for at different concentrations. So at different concentration, this value is known. Sorry, this this is already known. This value is already known. R is equal to rho and G star, right? G star is nothing but my cell constant. So this value is known in the market. For KCl, let's suppose 0.1 m solution, again KCl 1m solution, and again KCl you take 0.01 m solution. For all these values is known. This value is known. So if I know this, and this value I can actually know because the same setup which I have showed you, right? For example, instead here you take K plus NCl minus ion, you put in the Wheatstone bridge in the same structure, and you pass the current, and you just this is a variable resistance again. You just keep changing the resistance. At the point of time, you'll see that there is no current passing through this circuit. That means your Wheatstone bridge is all established, and in that case, you can say that R3 into R2 is equal to R4 into R1. So these three values you must be knowing: R1, R3, and R4. So R2 you can actually calculate. Correct. So these, and they also depend on constant temperature also. These values are all known at our different temperatures. Maybe you'll take 298 Kelvin, the room temperature. Correct. So with that, you can actually get the value of R. So you can do the same experiment 3 times. You'll get the same value of R. You can take the mean value of R. Alright. So that is one way. So if you know this, actually, this is something you can see experimentally using physics. So you can get the value of this. Right. What I'm trying to say is R is equal to resistivity into cell constant. This is known to you, right? You'll get a lot of tables in the market, in the textbook also for example, KCl and NaCl at different concentration, different temperature, this value is given. So let's suppose I took 0.1 m KCl at 298, and that value is given to be X. That is something I can get. This value R I can find from this experiment. If I put 0.1 m KCl, so this value is also I can derive using maths. So this values I can get, because now the equation will be y is equal to x into g star. So g star is nothing but y by x. Y is the experimental value we shall get. X is the value we shall get in textbooks for a given concentration of KCl or NaCl at a given temperature. Correct. So please note once again, the conductivity depends on temperature and concentration. We'll discuss more about this, how the conductivity varies based on temperature and in fact, we discussed a little bit about this. The moment you increase the temperature, the conductivity of electrolyte solution increase, but the conductivity of the metallic solution decrease. We have discussed this. We'll discuss this more again. Correct. So with this, if you see, I can get G star is nothing but R by resistance by resistivity. Resistance I'll find experimentally, resistivity I'll get it from the textbook. Correct. So here the equation we'll use is R1 into R4 is equal to R2 into R2. And please note here AC power is used for the Wheatstone bridge, because we are saying that for this solution itself we'll be using AC power, not DC power. This is the AC power actually. Correct. Now let's talk. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.